Hello. In this video, I'm going to show how to solve this problem of a collision between two blocks that collide elastically. So we have a block. We are told it's a 1 kilogram block. It is traveling at 10 meters per second, and it's going to collide with a 2 kilogram block that has no velocity at all. And we want to know what the final velocity of each of the blocks will be. Okay, so is elastic collision. So it's a collision. We can use conservation of momentum. It's elastic, so we can use conservation of energy. So I'm going to write conservation of momentum. I'm going to call this block A, and I'm going to call this block B. And I'm actually going to do this whole problem in terms of variables, and I'm only going to stick in the numbers at the end. So I'm going to call the first block's mass MA, which is 1 kilogram. I just don't want to write 1 kilogram because I want to do this in terms of variables. So MA VA. VA will be 10 meters per second. I'm not going to write it as 10 meters per second. Actually, let's just make that V instead of VA. Let's make that V. That'll be our initial velocity. Plus, so this is really 1 kilogram and 10 meters per second. I'm writing them as variables so that if I had to do this problem again with different numbers, I would just stick in different numbers into the end answer. Okay, plus 0 is equal to the final momentums, which is MA VA, and I could put a final, but I'm only gonna have one VA, so it'll be my VA final plus MB VB final, which I'm just gonna write as VB. Okay, so that is my conservation of momentum equation. I can also write the conservation of energy equation. 1/2 MA V squared is equal to 1/2 MB, or sorry, A, VA squared plus 1/2 BV squared. Okay. That's two equations, two unknowns. I can cancel my 1/2s. My two unknowns left are VA and VB. So two equations, two unknowns. Everything after here is math. So let's solve for, which one should we solve for first? Let's solve for VB first. Okay, so let's solve for V. We'll solve the top one for VA and plug that into VB. So solving the top one for VA, I can move the MBVB to the other side. I get MAV minus MBVB is equal to MAVA. You can divide both sides by MA. I'm just going to do it this way. MA. Well, actually, when I divide by MA, like this, the MA over MA will cancel, and I will get VA is equal to V minus MB VB over MA. I can then take that VA and plug it in there. MA V squared is equal to MA parentheses VA, which is V minus MB MA VB squared is equal to, no, plus MB VB squared. Okay. Let's see here. What do I do next? Okay, I want to find VB. Where is it in my equation? It's here and here. So I need to get it by itself. So I'm going to have to square out, FOIL out this parentheses here. So if I do that, I get MAV squared is equal to MA parentheses V squared minus 2MB over MA V times VB plus MB squared over MA squared VB squared plus MB VB squared. Okay, we can multiply in my MA, get MAV squared is equal to MAV squared minus 2, and then the MA, when I multiply this MA into this term, it cancels the MA in the bottom. I just get MB VB. When I multiply it in here, it cancels one of the ones in the bottom, and I get plus MB squared over MA VB squared plus MB VB squared. Okay, cool. I fortunately have cancellation. Those two terms cancel. I then am left with these. I want to solve for VB. I have a VB squared on these two, and I have a VB on this side. I'm going to move this one to the other side. So we get 2MB VB is equal to MB squared over MA VB squared plus MB VB squared. Okay, so you see there's a VB on both sides of the equation. So I can divide both sides by VB. But when you do that, you have to keep in mind, you can only allow to do that if VB isn't 0. If VB is 0, you're not allowed to divide both sides by 0. When would VB be 0? VB is 0 if block A entirely misses block B. Students right by, then VA will continue on and VB will just sit where it was. I'm going to assume they actually hit each other, so VB will have some non-zero value, so I can divide it out. Okay, then I can get 2MB V is equal to, I can pull the VB out of the other two sides, so I get MV squared over MA plus MB VB. Oh, wow, there's a MB at every term. And I can, why don't I multiply every side by MA so I can get rid of this pesky denominator. So I get 2MA V is equal to MB plus MA VB, or in other words, VB is equal to 2MAV over MB plus MA. Cool. So that is the velocity of block B. How might I find the velocity of block A? Well, I can just recycle this equation up here, recycle the conservation momentum equation. Let's just write that one down again. So that writing it down again is MAV is equal to MAVA plus MB times VB, but VB we know to be 2MAV over MA plus MB. We're trying to solve for VA. So I move this term to the other side. And, well, actually, we'll move that to the other side. So MAV minus MB2M. Okay, I can divide by VA, and I get V minus 2MB over MA plus B times V. I missed a V here. Times V. is equal to or VA. VA, I can actually simplify that a little bit more. I can combine my denominators, so I get V times, I can pull out a V, and I get V, combine my denominators, I get MA plus MB minus 2MB over MA plus MB equals VA. In other words, VA is equal to V times MA minus MB over MA plus B. There seems to be some symmetry about that. Okay. So those are my two equations for VA and VB. And that is how you solve a elastic collision where one of the objects starts motionless. Okay.